Okay, so here's the raw data. We've got participant ID, different groups, control group and ACL, which have dominant, non-dominant, involved, uninvolved legs, which I've also then split into healthy legs, involved, uninvolved. Then a range of kinematic variables, vertical force, penultimate foot contact, final foot contact, and change of direction speed. We'll just bring that data into JMP, and one of the early nice things we can do is just quickly examine all of the distributions there, have a bit of a look here, and you could split that obviously by control group, ACL, dominant, non-dominant, involved, uninvolved, which just gives you a nice little double check of, did I enter my data all correctly? Is there anything strange going on with any of these participants? Something I can see jumping out here I better have a bit of a look at later is this knee final foot contact value is a long way from all of the others, so we'll keep a bit of an eye on that. This is left over from previously, so I'm just going to delete those two columns. So we'll now do our analysis, and the first thing that we want to do is check the distributions of those. So we'll throw all of those together in distributions, have a look at that. And the nice aspect we can do here is this cross-highlighting, which you can see is highlighting the individual values if you see something a little bit strange. So again, here's this weird value just here, jump across to this, and is there anything strange about this data? Do we remember anything odd here that has this value for knee final foot contact such a long way from the others? We can see that cross-highlight in the others there. He's got a relatively high amount of hip final foot contact, knee flexion, but was this a data entry error or something else? I can confirm that we checked that and that's not the case, so we'll carry on with our analysis here. Next thing we want to do is analyze the distributions of all of those, which we'll also split by limb. Actually, just before I do that, since reviewers will ask for it, let's take the normal sorry, my mistake. Let's cast that to all of the values here, and we will get normal quantile plots for all of them. We'll also fit a normal distribution to all of those. Hold the control key down, continuous fit, fit a normal. And let's just maximize this window here, and on those fitted normal distributions let's check the goodness of fit, and so we can see that pretty much all of them are not normally distributed, so we're going to have to make sure that we do some non-parametric analyses, but more on that later. Now along the way here we want to make sure that we keep track of everything that we've done, so I'm going to put all of this into a journal. So I've just created a journal and kept all of those analyses, which I'll just pop off to one side here. I'll just close that one up. So I can now close this. Now we want to have a look at those distributions, and we'll split those up by groups as well. So this was our attribute we were analyzing by. We've now got the same thing, so in here I can also add normal quantile plots for all of those, and we'll also have a fit a normal to all of these. That's a little bit odd. Fit a normal to all of those, that's better. And then on all those fitted normal distributions, again let's just run our goodness of fit, which is now ran on all of those for both the healthy limb, involved, and the uninvolved limbs. We'll save that across because that's got all of our descriptors as well, anything we might need to do. So that's now in our journal here, so distributions for the healthy limb, the involved limb, and for the uninvolved limb. Alright, now I want to graph these data. We'll bring across to the graph builder here. Just give me some more real estate here. We'll start off with the hip penultimate foot contact, have a look at that and build out our graph. Now this is probably going to be sensible for us to be plotting these all as box plots. We can do a whole bunch of customization here if we want, and in this case I'm going to add a line So we've got values at the mean, obviously median for our box plot there, and if we wanted to do any other customizing, for example on the markers, change the marker, change the size, maybe we want to make all of these a positive grid for whatever reason. Once you're happy with that, any of the other customization that you want to do there, I can now bring hip, knee penultimate foot contact, knee final foot contact, ankle penultimate foot contact, ankle final foot contact, vertical force or pressure for penultimate foot contact, and final foot contact, and finally the change of direction speed. This is for our entire cohort, but what we care about is looking at those values by, we wanted to split those by the healthy, involved and uninvolved limbs, so we can just have a quick look here and see if there's anything jumping out of the data. Perhaps there's something going on here at the ankle final foot contact. Probably not. Sorry, ankle penultimate foot contact. Nothing much. Maybe there's something going on there, but it looks like we've got some values pulled out there by outliers. So we'll just drop that into our journal as well and now do some analyses. Let's jump over to the fit model platform, which is a real strength here. So we want to look at, there's all of our variables. And now we'll create our model, which will be limb as the model effect. Here we could do interaction effects if we needed to, but instead of standard least squares, I'd like to do a mixed model here, so I can have as a random effect all of the participants. We could change our covariance structure as we need to. This is not a time series, so I'll stick with the default of a residual. So we've got our limb value, which is healthy, involved and uninvolved, and as a random effect our participant ID. We'll run all of those and see what we find. I'll just take you through the very first analysis. All of the others are going to be similar. So our mixed model for hip penultimate foot contact, here's our random effects covariance estimates. So participant ID is significant, but we've got no residual, no total effect there, no fixed effect parameter estimates. So the only significant one is the intercept, which means this model's not significant. As we scroll down and check those, same thing, same thing. Here we appear to have knee final foot contact. We've got a significant effect for the involved limb. So let's just do some adjustments for multiple comparisons there. We'll show a least squares model and we'll choose Tukey's HSD as the adjustment for multiple comparisons. This still comes out as significant, so a difference between involved and uninvolved of somewhere between -24 and -5 or 4.5 or so. So that's our main one with that, so we'll keep an eye on that. While we're at it, we'll just, because we're going to have to check the veracity of that model later, so I'm going to save as a column the conditional residuals there, and we'll check that in a moment. We'll jump down here and see if we've got anything else, and it looks like for ankle penultimate foot contact we have something going on there. So ankle penultimate foot contact, let's check for multiple comparisons again. And now we have significant differences, healthy to involved and involved to uninvolved, but not healthy to uninvolved. So same deal, we're going to have to check the veracity of that model, so let's just save the conditional residuals of that model. And that's penultimate foot contact if memory serves. Knee penultimate, no, nothing there. Knee ankle final foot contact, nothing is significant. Vertical force, nothing significant. And change of direction speed, nothing significant for that. Okay, so let's just drop this into our journal as well, and then I can close that up. And then the last thing that we probably want to analyze is we found two models were significant. That was knee final foot contact, ankle penultimate foot contact. So we just want to check to see that those models are valid. This is looking normally distributed, but this guy isn't, and again it was that participant that we were a little bit worried about over here with a very large value. So it looks like there might be some leverage exerted there, but let's do the formal testing for this. So I also want to check the normal quantile plots, and again we've got one sitting way up the top here, which is that same participant. We'll fit a normal to this, and let's just check the distribution of that. So yep, as we are worried about, that model for the knee residual, the knee final foot contact, the residuals are not normally distributed, as evidenced by our distribution here, visual inspection of the frequency histogram, the QQ plot, and both of our goodness of fit tests, whereas the ankle penultimate foot contact, that all looks pretty good. So I'd be happy to hang your hat on this value. We would then need to go back and have a look and see if that makes clinical sense, which it turns out it does, but there's nothing going on here at the knee.